Iba na nakinilabay. Anyway, again, good afternoon. And for our session for today, our topic would be actually continuation lang no on our discussion with the topic simple stresses. No? So we are done with normal stress. And today, we will talk about shear stress no, or shearing stress. So shearing stress differs both, I mean, shearing stress differs from both tensile and compressive stress in that it is caused by forces acting along or parallel to the area resisting the forces. So, si shear stress class is dependent siya no, sa tensile and compressive stress. So, when we say tensile or compressive stresses, it is actually, or it refers to normal stresses. So, di ba, we are done with normal stress naman nga topic. So when we say tensile or compressive stress, mura na pud na siya o nag-refer to normal stress, no? So whereas a shearing stress may be called a tangential stress. So there are other books or there are problems nga mag-state siya na find or determine the tangential stress. So ang iha lang pasabot niya ana is ang shearing stress, no? So other name kibali ni shear stress is si tangential stress. So, by the way, gi-create na ako as co-host no si Joby Bastatas and si Joffrey kay para sila na ang mag-approve if ever napamoy classmate nga malate o join. Anyway, so going back to the topic, so we have this component for shear stress. So the shear force, no? So the shear force is designated as letter V. So sa iyang definition diri no, resultant shear force sometimes designated as V, but actually most of the time and the most common designation for shear force is letter V. So there are other books lang or other problems nga ang ilahang representation for shear force is letter T. And to avoid confusion with torque, so we will designate it na lang as letter V para dili ta maglibog, no? So these are components of the total resistance to sliding the portion to one side of the section past the other. So the formula for shear stress is represented by the Greek alphabet tau, no? Tau is equal to V over A or a force per unit area lang gihapon since it is a stress, no? It's just that V refers to the shear force. So katong force nga nagresist no sa force applied divide by the area where ang area nga atong i-consider is again parallel to the shear force. We have different types of shearing stress. First is a single shear, and then second we have double shear, and lastly we also have punching shear, no? So kaning punching shear literal yun na nga. If sumbago nimo ang isa ka plywood then mabuslot, so that is actually an example of a shear, punching shear rather, no? So kusog kaayo ang compressive force nga na-apply sa plywood in which wala niya na na sustain. And so nag-occur no ang punching shear. So mao na siya ang one basically example. So sige lang ato na siyang i-elaborate sa ato ang virtual whiteboard. So transfer lang ta for a while sa ato ang okay, so I think na-share naman siguro, no? So let me just copy the figures from our PowerPoint para hindi ako mag-drawing. Okay, so this is single shear, double shear, and punching shear. So for a single shear, so imagine nga naka-plate, then connected by a bolt or a rivet, which is kani siya. Then imo siyang gina-pull, gina-pull out nimo no ang both plates. So naa kay forces P acting oppositely directed no. So meaning naay ma-create ana nga shear stress no sa iyahang bolt kani si bolt or si rivet. So kani sa iyahang connection nga part. So if atong i-draw iyahang free body diagram, that is your force P and si bolt or si rivet. So on this part class, nag-create na siya og shear stress no. So naa na siya ginatawag nato nga shear force. So muna na si letter V no. So muna na siya iyahang internal shear force nga nag-occur gihapon. And that leads you to shear stress niya nga part dara mag-occur ang iyang shearing stress. So in this case, so summation of forces lang kano. Therefore, your P is equal to V. So meaning, force applied is equal lang dito siya sa ato ang shear force nga si letter V, no? And for double shear, and if kani po datong i-consider, so this is actually called a clevis, no? So you have a force or let's say resisting force P, and then imo pud ginabira kani siya nga object, no? Oppositely directed, mag-occur po ang shearing stress ana on this part, no? So I hope makita siya sa sa screen nga akong gina-highlight. So on these parts, napoy gaka-develop nga shear stress or shear force. So if atong i-draw ang iyang free body diagram, napod na siya shear force nga gina-resist, no? Which is CV. So in this case, our P is equal to 2V, no? Or V nato is equal to P over 2. So pwede nyo siyang express at that as that one, no? So for punching shear, this is actually called a circular slug, no? So naa siya gina-punch, no? So from the term punch or gina-duot, gina-compress sa isa ka plate. So let's say this is a plate. So ang shearing stress pod ana no or shear force pod na nag-occur pod siya pag i-draw. Okay. Okay, much better. So if mo na nining a hole no nga na-create sa ato ang punching force P. So ang shear stress pod ana nag-exist na sa iyahang circumference sa imong hole. So na po na siya gina-resist na force V. Excuse me. So pardon my penmanship na lang siguro class no or illustrations kay sensitive with ang mouse. Anyway, hoping next week maabot na to ako ang gi-order nga drawing pad kay para at least no mas convenient ang calculations or illustrations kay I think naman na siya pen so mas dali na lang siya unlike sa mouse gyud ang imuhang i-maneuver no to write or to draw so lisod gid siya anyway so ang shear force no nag-exist sa circumference sa imuhang hole but ang iyahang resultant shear force V is just equal to P no so in this case P is just equal to V but 'di ba I said that the area nga imong i-consider should be parallel sa shear force no nga nag-act sa ato ang object. So meaning if mo niya to ang shear force, ang atong area nga i-consider on this sa punching shear, kani pud siya no. Wait ha, to i-color yellow siguro. So kana pud siya to ang i-consider nga area. So if ato na siyang i-layout no, ang iyang circumference, so you have this as the thickness na of your plate. And then we'll take this as L or iyahang length in which your L is just the circumference no, of your hole. So area now therefore is equal to L times T, where again L is the circumference no, of your hole. So nahimo na siyang rectangular kibali. Okay? And then on this part pod, kang double shear, so if mo niya nga to ang shear force, then if ang parallel atong i-consider, so kani siya no nga area, meaning it's just the cross-sectional of your bolt no or your pin or if unsa na siya na object ang naa dinha. So in this case, it is a pin. So area lang siya sa imuhang cross-sectional area of your pin. So circular lang. So you know the area no for a circle. And then for single shear also, since kani man ang ato ang shear force, therefore kani atong i-consider nga area no, which means it is just also the cross-sectional area of your bolt or rivet or rivets no or pin. Okay. Okay. So let's proceed with our sample problems, no, to further illustrate our discussion on shearing stress. So di na lang ko mabalik sa atong PowerPoint. Ako na lang siyang piyahon and i-paste diri sa ato ang virtual whiteboard. So for sample problem number 1, determine the smallest diameter of a bolt that can be used in the clevis shown if P is equal to 400 kilonewton and the shearing strength for the bolt is 300 MPa. Okay. So ang figure is clevis, no, katong double shear. Muna siya ang figure. So ang gipangita sa atong problem is the diameter, no, of the bolt nga pwede natong gamiton for this clevis with applied force P equal to 400 kilonewton. And then gitagaan po ta og limit, no, sa ihang shear strength. So the shear strength therefore is only equal to or limited to 300 MPa, no. Okay. So again, if P is equal to 400 kilonewton, so let's try to determine, no, pila ang smallest diameter aning bolt nga pwede nato gamiton para dili siya mag-occur ang iyahang shearing stress, no, or iyahang di siya maabot sa iyahang limit nga shear strength. So ato lang i-apply ato ang formula for shear strength or shear stress rather. T or tau is equal to V over A. And since this is a double shear, no? So diri mag-occur ang imuhang shearing stress or sheared area. So in this case, shear stress is equal to V over 2A. So twice the area, no? Since duha man yang affected areas. So by substituting the formulas or the values rather, no, to the formula, you have tau or shear stress is equal to 300 MPa. So 300 times 10 to the power of 6 is now equal to 400 times 10 to the power of 3. So in terms of Newton, ang ako ang unit of force, no, over 2A. So wala tay area, no, or in this case, ang atong makuha ani is ang cross-sectional area for the bolt. Therefore, the cross-sectional area of your bolt is equal to area of bolt, no? How much is this? 400 times 10 to the power of 3 all over 2 times 300 times 10 to the power of 6. So you have area of the bolt 0.667 times 10 to the power of negative 3. So this is Newton per meter squared. This is also Newton, therefore cancel out, cancel. At our unit for area is meter squared, no? M squared lang. So if ato siyang i-express in terms of millimeters, so area of your bolt is equal to 666.67 millimeters squared, no? Okay? But dili man area ang gipangita, no? Since the problem states that determine the smallest diameter of the bolt that can be used. Okay. So by using the area of the bolt nga to ang na-obtain here, makuha ra pod nato ang diameter, no? So area of the bolt is equal to area of your circle, no? Since the cross-sectional area of a bolt is just circular. So pi r squared, where area is equal to 666.67 millimeters squared, equal to pi r squared. Therefore, you have a radius of the bolt equal to 14.567 millimeters. But since diameter ang gipangita, so ato lang siyang i-times 2, no? So diameter is equal to 29.135 millimeters. Okay? So actually, you can use directly the area provided for a circle nga diameter, no? Or diameter ang iyang component. So it's just area is equal to pi d squared over 4. But for me, manggod, personally, naanad ko radius. So radius ako ang gagamiton. So basin, matingala mo nga, sige ko gamit og radius, no? So anyway, it's just the same, no? Regardless. So this is now our final answer. Diameter, or the smallest diameter that a bolt, or the smallest diameter of a bolt that can be used in the clevis is equal to 29.135 millimeters, no? Okay, sige. I hope naka-follow, no, or naka-follow po ang pag-take notes ninyo. So, okay, so proceed na ta with our next example. Okay. So sample problem number 2, a hole is to be punched out of a plate having a shearing strength of 40 KSI. The compressive stress in the punch is limited to 50 KSI. Then compute the maximum thickness of plate in which a hole of 2.5 inches in diameter can be punched out. If the plate is 0.25 inches thick, determine the diameter of the smallest hole that can be punched. Okay. So you have two ano, problem. So first is ato na lang siyang i-label na as A. And then second one is si B. So I think much better na siya. So you have a hole that is to be punched out pano out of a plate having a shearing strength of 40 KSI. And then the compressive stress in the punch is limited to 50 KSI daw kuno. Okay, for letter A, compute the maximum thickness of the plate in which a hole of 2.5 inches in diameter can be punched out. So you are given a diameter of the hole, 2.5 inches. So thickness is unknown, which is mo ang gipangita no for problem A. We are also given shearing strength. So 40 KSI. And a compressive stress that is limited to 50 KSI daw kun ano. So unsa man ni si compressive stress? So 50 KSI daw kuno iyahang limit for its compressive stress. So again, when we say compressive stress, di ba, it only refers to the normal stress. So ako na siyang ingon kaganina that if I will say tensile stress or compressive stress, it is just the normal stress, no? Therefore, this stress limit pala is a normal limit, no? Or if a normal stress. So, compressive normal stress. So, nganong included man na siya sa ato ang analysis here, no? Anong itagaan man to og normal stress. Now, we're dealing with shear stress man. So, of course, walang sa idro ha. So, mura siya sushi. Anyway, so if mo na siya nga hole no ang imong i-punch out of the plate and you have shear forces no or yang resistance niya no or ato siyang i-represent as a resultant force shear V. So wala ta kabalo kung pila yung value ni P. So wala ta kabalo kung unsa ka kusog no ang iyahang force. That's why nag-exist ni ang ato ang compressive strength. So to determine that one, 'di ba? Normal stress is just equal to P over A, where P or I mean, where the area nga atong i-consider is perpendicular to P. Kani siya. And since we are given a diameter, to ma-compute na to ang area, no? So natay diameter sa hole, then gitagaan ta og limit, no, for its compressive force or compressive stress rather, 50 KSI. So meaning ma-obtain na to ang force P, no? So nganong importante mo na siya sa tong analysis? Because mo po na siya to ang basis, no, for our shear force nga si V. So we cannot proceed with our equation for shear stress that tau is equal to V over A without knowing the magnitude of your force P. So again, dependent man gud si shear stress, no, sa force nga nag-act saya perpendicularly. So kung imo na siyang itulod, so managi siya somewhat resistance to sa ilahang connection nga part. And that is what we call the shearing stress or the shearing force nga nag-exist ang shearing area. Okay? So you are given compressive strength or compressive stress rather equal to 50 KSI. So times 10 to the power of 3. Then pound per inch squared na lang ni siya, no? Is equal to, so this is just from the formula na normal stress is equal to P over A, ha? So P over area nga, pila man na to ang area. So area nga to i-consider, so circular area. So area of a circle lang, which is pi r squared. So which is the diameter of your hole or the circular slug is 2.5, no? So 2.5 over 2 squared. Therefore, ma-obtain nato ang ato ang punching force, no? Ano itong ginatawag nga punching force, si P. Kung unsa ka kusog, no, ang iyahang pagtulod. So anyway, that is 50 times 10 to the power of 3. Oops. Times pi 2.5 over 2 squared, meaning you have a 245,436.92 pound force. So, inani kakusog ang iyahang gi-exert na force. So, if ato na siyang i-express in terms of kips, so we know that 1 kip is equal to 1,000 pounds. Therefore, you have 245.437 kips. Okay? Okay, now, compute the maximum thickness of the plate in which a hole 2.5 inches in diameter can be punched. So by using the equation for our shear stress, you have tau is equal to V over A. In which case, nga ang ato na pong i-consider nga area is the area parallel to shear force. So if kaniya tong shear force, then ang atong area nga i-consider is the circumference, no, of your circle or of your hole times the thickness of the plate. So if ato na siyang ibali if nakay papel ba, no, nagi roll as a circle, then imo siyang ibuklad. So inana kibali ang iyahang analysis. So this is the thickness of your plate times the length or the circumference of your hole. Okay. So we have shear stress na limit, 40 KSI. So 40 times 10 to the power of 3 is equal to V, CP lang, no? 245,436.92 pounds. Since ang ato ang shear stress in terms of pounds na ni siya, no? Pounds per inch squared. So divide by the area, or if ato siyang i-directly express atong area, no? So area of the affected area is parehas lang siya sa rectangular, no? Since ato naman siyang gibuklad. So length times thickness lang. Where L is the circumference of your circle or slug, meaning this is 2 pi r. Okay. So makuha na to ang thickness, no? Since r is given, or the radius of your circular slug, pila to siya? 2.5 over 2, no? So ako na lang siyang ibutang diri nga given. So kamo na substitute. So pila mo na ang thickness sa plate na allowable? You have 40 times 10 to the power of 3 times, I mean, 245,436.92 divided by 2 pi or nga 2.5 over 2 times 40 times 10 to the power of 3. So 0.781, no? So let's practice 3 decimal places, class. So 0.781 inches. Okay. So this is our answer, no, for letter A. Compute the maximum thickness of plate in which a hole 2.5 inches in diameter can be punched out. And then for letter B, you have if the plate is 0.25 inch thick, determine the diameter of the smallest hole that can be punched. Okay. So for this letter B, gusto ko nga kamo ang mag-answer, no? So I'll give you, sige, 10 minutes. So by 4:05, so 3:55 na karon, no? 4:05, if na ay maka-answer correctly, no, and can show and explain sa iyang solution, then I'll give you plus 5 points sa inyong assignment lang or seat work. So wala pa tayo assignment or seat work, pero nanangoy additional 5 plus 5, no. So if na ay maka-share, no, sa ilahang correct answer. So sige, go. So of course, if miskan isa lang, no, ang maka-answer sa inyo nga correct, then kibali mo siya all for one, one for all. So kamutanan ang naay plus 5 points sa inyong seat work or assignment. So dili siya sa quiz mo add, ha. So if you want to answer, just raise your hand, no, or just click rather the raise hand button.
I think naka-mute ka, sir.
Ay, sorry, no, na-mute di ay. So, analyze na lang, no, if unsay pasabot sa problem or unsay pasabot sa statement. So, that is part of your development no, sa inyong problem solving skill.
Kanang B, sir?
Yes, ang letter B. So, try to answer letter B. Okay, for a while, na ay nag 7.8 inches. No, dili siya 7.8. Sige, ato na lang siyang ikuan sa centimeter, no? Para,
Kaganina nasa kay
ay, okay. Nakamute dahil ko, sorry. I think na ay nakakuha sa answer. So, kindly share it sa inyong classmates. Si Nisperos Paul Vance.
Dili man ko kabalog explain sir kung saan ako kuha.
Sige lang, itry lang siya og um, explain. So, anyway, ikuan lang siya kung unsa nimo ang process or unsa imong analysis.
So first na akong gibuhat is the times na ko ang sa siya. Parang 50k is ay sa ano A sa 1/4 pi d squared. So ang kuha na ko nga sa P is 12.5 pi d squared. So ako din gi-con din sa V konda yun nga V is equals to TA. So kay kung may kwaon, nalibot ko sa man. Anong may kwaon ning diameter, so ako siyang gibalin sa pikas. So nahimo siya 12.5 pi d squared equals to 40 times pi d times 0.25. So equals to diameter equals to 0.8 inches. Sir.
Okay. So, correct no? So, sakto ang imong process actually and imong analysis. So, 'di ba same lang yapon siya og for a while asa ato ang whiteboard. Okay, anyway. So, the same lang siya og uh, case no with letter A. It's just that nabaliktad no. So, instead of diameter ang given sa letter A, so sa letter B, diameter ang gipangita. Then, gihatag ang thickness sa plate. So, sa letter A, thickness sa plate ang gipangita. So, kibali mo nag-switch lang kibali siya, no? But the analysis and the procedure is just the same. So, we'll try to solve letter B. So, if the plate is 0.25 inches thick, so tagaan taog, thickness sa plate, determine the diameter of the smallest hole that can be punched. Therefore, diameter ang gipangita. So, still, no, the same parameters given. Shear strength is equal to 40 KSI. For a while, basin na, kaya naka-mute ko. Anyway, so compressive stress yapon in the punch is limited to 50 KSI lang gihapon. So, maura siya, no? Ang ato ang given. So, again, we need to determine first the force, no? If pila ang punching force nga exert sa ato ang circular slug, no? Kani siya nga figure. So, ato lang siyang igamiton no, ang iyahang relationship with the normal stress or compressive stress. So, 50 KSI, 50 times 10 to the power of 3 pound per inch squared is equal to P, which is unknown, no, patakabalo. So, we cannot use this one, kani siya nga P. So, nga naman, kay ang atong i-consider din is 2.5 inches ang iyahang diameter sa hole, no? So, nag-state si Problem B, that ang diameter ang ato ang ginapangita. So meaning, dili na siya ang ato ang dili ni ang ato ang P or kaning force nga nag-act kang letter A, ang ato apong force nga nag-act kang letter B. So lahi na po siya nga kibaling scenario. So P over A, where our A is just the area of your circular slug, no? Since this is, again, normal stress, so perpendicular to the force P ang imong i-consider. And that is just the circular or the cross-sectional area of your circular slug. So you have pi r squared as the area. So radius is still unknown since gipangita pa man nato ang diameter, no? Therefore, we can will have an equation for force P, and that is 50 times 10 to the power of 3 times pi. You'll have 157,079.633 pound force. Oh, sorry. Um, 157,079.63633 r squared, no, pound force. So, i-express na to ang P in terms of a radius. And the next step is ato nang gamiton no ang iyahang shear stress. So shear stress is equal to V over A, where shear stress is limited only to 40 KSI. So this is 40 times 10 to the power of 3 is equal to V, which is ang atong P lang. So pila to siya? For a while, hala na, unsa na ni. Okay, I've been hold. Nag-crash. Anyway. So P is just equal to V, no? R squared all over the area. So again, area nga itong i-consider
Sir,
is,
na-stop ang share screen naman, sir.
okay, so nawala gid ay siya for a while ha atong Okay, so thank you sa pag-notify, no? Anyway, going back sa topic, ang area na to i-consider again is area parallel to the shear force. So ang nahitabuan ni class is if ato siyang ilatag, no? This is the thickness of your plate and then length, no? Where length is just the circumference no, of your circular slug. So if P, so side view kibali no sa coin or sa slug rather. So if this is the isometric view, then if tanawan nimo siya sa iyang side view, so inani iyang itsura where this is P and ang iyang shear force resistance V or represented by the resultant force V. So P therefore is just equal to V, in which we have here an equation for P, 157.79.633 r squared all over area. So area nga to i-consider is kaning parallel sa to ang shear force V. So naka-rectangular siya, no? And that is just a thickness times the circumference of your circular slug. So 2 pi r. So since I'm using radius, so in terms of radius po ang ako ang formulas na panggamito, no? So ma-cancel out ang isa ka r. And thickness is, by the way, given na siya, no? So ako na lang siyang i-substitute directly. Thickness is 0.25 inches. Therefore, makuha na to, no, ato ang value for r or ang iyahang radius. And how much is this? You have 40 times 10 to the power of 3 times 0.25 times 2 pi all over 157,079.633. So radius is equal to 0.40 inches, no? Or the diameter is equal to 0.80 inches. So in his case, no, kang Mr. Nisperos, in terms of diameter, no, ang iyang gamit, which is more convenient since pag makuha na nimo ang D, so di na ka mag-need mag times 2 para makuha ang diameter, no. So again, naara siya, no, sa inyong style or asa mo comfortable. So this is our answer for letter B. The smallest diameter that a hole can be punched out is equal to 0.80 inches. Okay, I'll give you time to copy. Ay, na-copy naman siguro ni, no? Kaming letter B na lang. Okay, so as promised, you'll have your plus 5 points, no, sa inyong seat work or assignments. So, i-record na ko na siya later para dili ko malimot. Sige lang. Anyway, by the way, tuod class, no, I hope nga na-briefing na mo about sa inyong calculator during your first year sa ato ang profession. Okay. I have a student last semester, I mean, not last semester rather, but last week, na student nga nag-approach sa ko ano if unsa daw calculator nga recommended for an engineering student. So, actually, ang recommended, no, for an engineering student before is ang Casio FX 991 ES Plus, but around 2019, giban na siya sa PRC. So, dili na siya magamit during board exam. So, if I were you, mag-invest mo sa inyong calculator. So, kato na lang calculator nga magamit ninyo, no, until the board exam. So, mahal, medyo pricey gid ato ang calculator nga need. So, it cost around 1,100 and up ang scientific nga calculator nga suitable for our course. So, now, I think ang best recommended nga calculator for CE is ang the same brand, no, Casio FX 570 ES Plus or Casio FX 570. So any ano na dayon, MX ba na siya or MS. So it possesses the same functions, no, with Casio FX 991 ES Plus. So naa siya the same sila og functions kibali. It's just that ang difference lang nila is ang power kibali, no, or ang source of power sa calculator. So sa 991 ES Plus, a two-way system iyahang power, and then sa 570 ano lang siya, one-way power lang siya, no, which is sa battery lang siya nag-depend. So regardless, ang iyang functions, it's just the same. So okay gyud siya ang 570 nga calculator class. So for our last example for this meeting, we'll have problem number 3. Excuse me. Okay. So sample problem number 3, compute the shearing stress in the pin at B for the member supported as shown in the figure. So the pin diameter is 20 millimeters. So we are given diameter of your pin, and we are asked to determine or to compute the shearing stress in pin B. So meaning, ang gipangita is si shearing stress. So si tau B. So formula for shearing stress again is equal to V, or shear force V over area, no? Or in this case, at point B, so meaning shear force at point B all over the area of the cross-sectional for point B, or for the pin, no, at point B. Okay. So walay problema sa area, no? Kay gihatag man ang diameter. So atong problema lang is ang iyahang shear force nga si VB. Kay wala siya gihatag, no. So meaning ato siyang i-determine. So how do we compute for shear force at point B? So by applying our knowledge on statics of rigid bodies, no. So we will treat this as a force system, no. So you have a roller reaction. I mean roller support rather. A roller support at point C and a pin support at point B. So meaning, once a roller gali atong support, we only have one reaction, no? And that is perpendicular to the surface of your support. So this is RC. And then at support at point B, since this is a pin support, so we have two natures, di ba, of support sa to or two reactions rather at pin support. So you have horizontal and vertical reaction for point B. So we'll name this as RBY and RBX. Okay? So ato sang ipang compute, no, or atong ipang determine ang mga reactions nato sa ato ang supports. So at point C, I think dili man siguro importante no ang reaction nato kang point C, kay ato ang analysis is more on naa kang point B, kay siya man ang ipangutana sa problem. Okay? So atong pangitaon is si RBY and si RBX. So how do we compute for RBY and RBX? By summation of moments, no, at point C. So if you'll take summation of moments at point C equal to 0, where counterclockwise is positive. Okay. So RBY will create a positive moment, no, with respect to point C. Therefore, RBY times its distance, no, to point C, it's just 250 millimeters or 0.25 meters. So dagko kay for a while. So 0.25 meters, no? So ako lang siyang gi-express in terms of meters. So unsa pa man nga force. So RBX will just be canceled, no? Kay diri man na siya nag-act si RBX class, oh. And again, property sa tong moment, no, or wala siya moment arm. So ma-cancel out lang na siya nga force. So any force nga mo pass through or moagi sa imong point of consideration kung asa ka nag-take og moment, that is just equal to zero. So therefore, ma-cancel na si RBX, leaving us with force A na lang, no, ang naay contribution sa ato ang moment at point C. So lisod siya i-determine since by definition dapat ang perpendicular, okay, wala na siya nagto, perpendicular distance, no, of a force A to point C. So atong gamiton nato ang Varignon's theorem, no. So the very famous Varignon's theorem na ato siyang i-break down into its components. So x and y components of your force A. So how do we find x component of force A? So that is just 40 cosine 35 degrees, and also your y component of your 40 kilonewton is just 40 sine 35 degrees. So ito lang siya i-label as RAX and RAY. So by this, mas dali na to ma-compute no ang moment kay naman tayo establish distances. So for RAX, with respect to point C, it will create a clockwise rotation, which means that minus, no, or negative ang iyahang sign convention. So minus 40 cosine 35 degrees times the moment arm of your RAX to point C, 0.20 meters. Okay, so nara class. So principle of transmissibility is just the same. So for RAY, with respect to point C, will create also a negative moment, no, or a clockwise rotation, meaning it will create a negative moment. So minus 40 sine 35 times its moment arm to point C. So kanilang siya, no, so si 250 millimeters or 0.25 meters. Equal now to 0 since wala na may lain force nga tong i-consider, no. So na-consider na nato siya tanan. So meaning the only unknown sa atong equation is si RBY. So makuha nato siya, no. Ma-obtain nato ang value for RBY. So RBY is equal to, so pila man ni siya. So if atong i-transpose ni siya nga expression, no, sa left ay sa right side sa to ang equation, so ma-positive siya tanan. Walang i-delete. Therefore, RBY is equal to 40 cosine 35 times 0.20. I hope mag-calculate po mo, no, para maka-follow. So plus 40 sine 35 times 0.25 all over 0.20. So you'll have, oops, for a while. Yeah. So you'll have 49.156. So unit our force or our RA is in terms of kilonewton, therefore kilonewton, no? Oops. So, ato lang siyang i-underline since dili man yung atong final answer. Okay. So, now, let us try to find RBX, no? So, the second component of our force, RB. So, si RBX, so dali lang siya na pag-identify class no or pag-obtain sa iyang value. Since if you notice or if you observe sa tuang system, we only have two forces no acting on x-axis no or horizontal components nila. And that is just RAX and your RBX. So meaning, pwede na ta mag summation of forces on x-axis equal to 0, which is RAX, so going to the right, so positive value or positive sign convention, minus RBX, no, since going to the left, equal to 0. So meaning RBX is just equal to RAX, which is RAX 40 cosine 35. Oh, 35 rather, no, sorry. So meaning value for your RBX or the magnitude of your RBX is just equal to 32.766 kN. Okay. Therefore, oops, di lagi siya final answer. So ato lang siyang i-underline. Kaya para di na kayo daghan box no ang ato ang solution. Therefore, our magnitude or the total force acting on point B or pin B is just the magnitude no, of your resultant, I mean, the magnitude of your components. So resultant force is just equal to, resultant force of point B is equal to RBX squared plus RBY squared. So substitute the values to obtain RB. So pila man ni siya. RB therefore is equal to 59.076 kN. So this is the total magnitude acting on point B. However, dili na siya mao ang gipangita no. So compute the shearing stress. So shearing stress ang ato ang pangitaon. So by the way, mo ni siya no si point, I mean si pin at point B. So naa siya dira, meaning if mo ni siya ato ang ato lang ipadayon no. Kani kibali nga view class no kaning arrow nga akong gibutangan. So diri nga part, so murag kung atong tanaan murag likod kibali niya no. So if this is force A, meaning ang shearing no mag-occur diri nga part. So duha ka buok. So this is a case of double shear. So duha ka area or two parts of your bolt is affected no. So meaning Next page na lang. Shear stress is equal to V over 2A rather. No, kay double shear man siya. So what happened is that at point B or the bolt no at point B naa siya shear force nga si RB. So parallel sa ato ang shear force ang atong i-consider. So it's just a circular cross-sectional area no, of the bolt. So this is tau or shear stress at point B. Pwede nato siya i-label as tau B. Is equal to RB all over 2A. And this is equal to pila tong RB. You have 59.0 or if ato siyang express no in terms of Newton, so 59,076. 59,000 Newton divided by 2A, 2 times the area no, of your cross-sectional area sa imong circular bolt. So pi r squared where radius no, is given. So diameter is 20 millimeters. Therefore, this is 0.02 all over 2 squared so we have shear at point B. So this is tau ha. So you have 94 million 0.22374.18. This is in Pascal, no? Kay ato mang force is in terms of Newton, then divide by meter squared. So Newton per meter squared is actually Pascal. Or we can express this no in terms of kPa or MPa. So if ato siyang MPa, so i-move lang nato siya no by 6 decimal place. So you'll have 94.02 MPa. So basically class, ang stress no, it is expressed in MPa usually most of the time good. That's why kaanad na lang mo no nga i-convert siya in terms of MPa ang inyong stress. Okay. So any question or clarification class?
Apan siguro, sir, kapuliki lang og input sa calcu sa mga solvings dere.
Okay. So actually no, dako yapon ay nagyapon na siya factor. Maka-contribute gyapon na og factor ang inyong pag-calculate sa calculator or kana pag-input ninyo sa inyong values sa calculator. So I hope nakabalo na mo unsaon pag-use sa shift solve na function no sa inyong calculators. Kay dako na siya help actually ang shift solve nga function sa calculator.
Si Sir, pwede may maka-SS atong sa last part, sir.
Okay. For a while, ato sang i-next ha.
Okay, daming. Thank you, sir.
Okay. So, Joby, nabay question? Nagpataas ka sa imong hand.
Sir, yun sa lagi itong moment of forces, sir. Okay, kato kung kakalibugan sa SRB, sir, like kung saan pag-identify, how come na f of x kay RAX ang gigamit? Help, sir.
Okay. So, ay, okay na ba nino? Na-screenshot raman no? So, I think, nakuha naman siguro. Same, sir. Galibog ko gamay sa moment. Okay, hala, nga naman, maglibog pa mo sa moment. Supposedly, dapat master
Sir,
na kayo ana sa
reading
stats.
session man to, saan man na mo pagsabot ko, isuti lang, o kamaon na mo ani, i-times na inyo, hala, wala mo gid.
Okay. So, anyway, we still have time man, no? So, 4:38 pa man. And, so, di na lang ko mag-attendance. Kay, kompleto man po siguro mo. Kay 42, tani abot tag 42 sa to meet. Niya,
Yay.
40 lang mo enrolled. Naunsa man, okay, I think sa ako, no, included mo na ko sa count as well as ang PowerPoint. So, sige. Okay. So, dapat class, expert na kayo mo anang summation of moment, no? Kay mo gyud ang pinaka-basic sa ato ang engineering mechanics class din. Pag abot ninyong higher subjects na to sa structural design, mobalik gyapon mo sa summation of moment or summation of forces, pagkuha sa reactions. So, mo gyud ang pinaka-basic nga solution or steps sa ato ang structural designs. Anyway, sige. So, summation of forces, wait ha. Sir, pwede mo disconnect, sir, na lang ko yung buhatan. Okay, so, pwede na, no, kay, actually, human naman ato ang meet, supposedly. So, ato lang ning, or extension, no, for those naglibog pa sa moment, or sa mission of moment nga concept. So, we'll have another example na lang, kay para, mas masabta, no. Kani manggod nga figure is, ano na siya, medyo complicated or much advanced. So, balik na sa to ang core basic. So, when we have a beam, so supported by a pin support and a roller support, so I hope nga kabalo na pod mo no sa nature of supports and basic loading. So, let's say this is our point A and point B, and you have force or loading, no, concentrated load at the center of your beam, which is P. So let's say this is L2 and length 1. So from P to point B, L2 ang ihang length. Then for P to point A, you have length 1, no? Okay. So ang moment class by definition is just actually force times the distance, no? Kung asa ka mag-take og moment. So muna iyang definition or ang iyang formula. So mura lang siya torque actually. So moment by definition is equal to force times distance. So M is equal to FD lang, no? So you have to understand also that lasaba lagi ang gawas. Anyway, the distance, no, nga ato ang i-consider here sa ato ang calculation should be perpendicular, no? Perpendicular to the point of reference. Meaning, if you have, okay. So, the same, no? Ato lang kopyahon, no? If you have a force nga naka-incline So this is force P. If mag-take kag moment at this point, kang point A, dapat ang imong i-consider nga distance should be perpendicular sa force P. No, kana dapat siya. So in this case, lisod man siya pangitaon, no? So mas easier kung kani nga distance atong gamiton kay one, either gihatag na siya or dali ra siya makita, no? So in this case, makita man ni siya but taas imong process, no, or mag-involve siya og trigonometric or trigonometry in general. So in this case, if mag-take tawag moment kang point A, so summation of moment at point A equal to 0, having a counterclockwise as positive. So by the way, no, so actually murag taas-taas mo gud ni siya nga supposedly concept ni moment, but I hope nga kabalo na mo sa sign convention pod ni moment. So wala may mali sa sign convention. It's just that dapat consistent kasi mo ang sign convention. Meaning, if you take counterclockwise as positive, therefore, dapat ang imong counterclockwise is naka-positive na siya nga values na, no? Then, the clockwise rotation would be negative. So, in this case, summation of moment at point A equal to 0. You have, so sige, reactions, RB, and RA. So if mag-take tag moment at point A, meaning ang ma-create unsa man ma-create nato nga rotation, no, ni RB. So if imo nang ipin, no, so lahi ra gyud face to face kay mas easier ang demonstration. So imagine nga imo ni siyang gipin, no, sa imong hand, and then imo ning gitulod, no, sa imong second hand ang point B. So na siya tendency nga mo rotate, di ba? So let's say free end ni siya, no? Then imo ning giipit ang point A. So na siya tendency nga mo rotate. So ang imuhang basihan for rotation is of course kana siya nga direction, no? So in this case, with respect to point A, ang imuhang reaction at B will create counterclockwise rotation, right? Therefore, positive ang iyahang sign convention, meaning you'll have RB times the distance. Kay formula na to for moment is equal to force times distance. So force RB times the distance, no, the perpendicular distance of your RB to point A kung asa ka nag-take og moment. So kani siya, meaning L1 plus L2. And then unsa pa may lain force nga na involved no sa ato ang system. So of course, si force P. So if si force P pod with respect to point A, again ipita si point A, then imagine na nga gitoklod nimo ang kaning stick. Let's say mo ni siyang stick nimo, no? Or nag-apply ka og force P. So it will create it will have a tendency nga mo rotate siya, no, nga ani nga direction. So kung tukloron nimo na siya ani nga orientation, so mo rotate na siya, no, at this orientation. And that orientation or that rotation is clockwise, no? Kung imagine na lang nga ang point A is ang imuhang center sa imuhang clock, no? Or muna siya ang imuhang center sa clock. Then mo ni ang imuhang moment arm or minute hand rather, no? So it will have a clockwise rotation, meaning negative, no? Kaya nga itong man ang assumption is positive ang counterclockwise. So meaning force P will create a negative moment with respect to point A. Therefore, P times the perpendicular distance of force P to point A, which is si L1 lang, no? Okay? So, napa ba yung laing force involved? Di ba wala naman? So, si RB lang o si force P. So, equal now to 0. So, if given ang imuhang P, ang L1 and L2, makuha nimo ang reaction no at B. Kay i-transpose nimo siya sa pika side, divide by L1 plus L2, then you'll have your reaction at point B. And then if kuan po nimo ang reaction at point A, pwede nimo nga magkuan lang ka, no, mag summation of forces ka again at point B. Kay again, isa ka assumption, isa ka consideration ni moment is that any force no or any forces nga mag-agi sa imong point of consideration, makancel lang na siya. That will just equal to zero. So by analysis pod, of course, since moment is equal to force times distance, if ang imong force moagi kang point B or kung asa ka nag-take of moment, distance nimo is just zero, di ba? So meaning, a moment is equal to force times a zero is equal to zero. So inana lang kibali iyang concept class. That's why if mag-take kag moment at point B, dili nimo siya i-apilon si RB. Kay naman siya kang point B. Therefore, if mag-moment ka og mag-summation kag moment at point B, you will have RA and si point B. I mean, si force P rather, no? Ang involved nga forces. However, if makuha na nimo si RB no sa ani nga step, actually pwede ra ka mag summation of forces on y-axis. So ngano man. So di ba these are the three equations nato no of equilibrium. Summation of forces equal to zero. Summation of forces on y-axis equal to zero. Summation of forces with respect to x-axis rather is equal to zero, and summation of moment is equal to zero. So we have three equations of equilibrium. So always remember you that class. So if nakuha na nimo si RB, if mag-take og summation of forces on y-axis, so pwede na no, if given si P, then na-obtain nimo si RB. So unsa man nga mga forces ang acting on y-axis, di ba? Si P, si RB as well as si RA. So if given ang P, then nakuha nimo ang RB. If mag-take ka og summation of forces on y-axis equal to zero, then makuha nimo si RA. Kay siya na lang man dayon ang unknown sa equation nimo, no? So ina na lang iyang concept class. So why ato man siyang gina-equate to zero? Kay again, these are the equations of static equilibrium, meaning our system must be in equilibrium. So they must be unequal, no? So therefore, mag-balance out lang dapat ang forces no or ato ang reaction sa ato ang system. That's why dapat ang resultant nato nga force is equal to zero or summation of forces is equal to zero kay para ma-obtain nato ang static of equilibrium. So if naa na siya value, meaning dili stable ang imuhang structure no or wala dili siya in static equilibrium. So ano lang yun siguro, practice na lang yun mo og solve no sa inyo sa moment and reactions kay we will be needing that one, especially most especially yun sa okay, so this is strength of materials na mga subject no. So nakahuna-una ko og dynamics. So gamit kinato na siya diri class sa ato ang sa ato ang strength of materials nga subject course. Napata sa stress no, but after ani ang preceding nato nga mga topics, it will require us our basic knowledge yun on statics, which is kaning static of equilibrium nga equations no, sila moment, silang forces. So I hope nga nasabdan gyud na siya. So I hope nga it helps no gamay. I hope nakatabang siya gamay kani nga explanation
Ako kayong tabang sir.
as to your understanding on moment and forces. So nganong ano man sad no, nagwonder ba mo nga nganong always magyud summation of forces, summation of moment equal to zero. So dili ka always mag-assume class nga summation of moment is equal to zero. That is actually depending on your kind of support. So if you have pin support and roller support, then wala gyud na sila resistance to moment. Wala na sila capacity no to resist moment. Therefore, that's why ang atong assumption always ana nila nga reactions or nga supports rather is a summation of moment at that support is equal to zero. So dili ka maka-assume nga at any point ka mag-equal to zero no. So for example, maingon ka nga at this point gusto ko nga mag-summation of moment diri nga part equal to zero. So you cannot do that because wala man kay support no nga nag-exist on that point. So dili ka maka assume ana always class. So ang ato ang assumption on summation of moment equal to zero is always on naa siya sa support class. Either si pin support or si roller support. So that is another discussion upon no for the nature of supports and reactions actually. But if naa kay restrained, I don't know if you're familiar with restrained beams, no? I hope nga na-encounter ninyo siya. So, cantilever, no? Cantilever, you cannot say that at this point or at point A, kani siya nga point no where asa ta ang cantilever, your moment is equal to 0. So that is not equal to 0 actually, class. Your moment there is not equal to 0. So naay moment nga nag-exist here sa imuhang cantilever. So sige lang, ma-encounter gid ta ni siya as we progress no sa ato ang discussion. Included ni siya here sa ato ang mechanics of deformable bodies. So this time dili ka makaingon nga summation of moment is equal to 0 because a cantilever or ang imuhang cantilever support naa siya capacity to resist moment. That's why na-value imuhang moment to at this point. So always remember that at pin or roller support, always safe ra ka no mag-assume that moment at that point is equal to 0. Basta class, ano lang yun siya, always stick to the definition of moment, no? Kani siya, force times distance, in which the distance nga dapat nimo i-consider is should be perpendicular with respect to the point kung asa ka nag-take of moment, no? So, parehas ani. So, going back here. Diba? Kani siya, si force A, naka-incline. So, maglisod taw determine sa iyahang distance no, or perpendicular distance padulong kang point C. Diba, wata kabalo kung pila ni siya nga distance. So, kapoy kayo mag-trigonometry, ato pa ni gamitan og triangle and etc. So, pwede ra nga atong gamiton ato ang Varignon's theorem. So, I hope na na-cover po na ninyo ang Varignon's theorem no last semester sa inyong statics. So, it actually states that ato lang siya i-breakdown no, sa iyahang components. So, if you have an inclined force, so pwede nimo siyang i-breakdown into its components para mas easier ang ato ang pag-determine or pag-summation of moments. No? Since if ato siyang i-breakdown, then we have the established distances, no? Na pwede na to gamiton sa ato ang summation of moment. Kay again, it should be perpendicular to the point where asa ka nag-take of moment. So if you're wondering, muna siya nga distance atong i-consider, no? We also have the principles of transmissibility. So when we say principle of transmissibility, so okay, if ato na siyang i-extend, no, ang atong RAX, so at the magnitude of your RAX at this point is just equal to the point nga naadiri, no? That's muna siya to ang principle of transmissibility. That's why muna siya iyahang perpendicular distance of your RAX with respect to point C. And that is just equal to kani siya, no? 200 millimeters. Okay, so we have 5 minutes left na lang, no? So, I really hope nga nakatabang to siya gamay, no? Nga explanation class kay para at least you'll know how to deal with our problems here in mechanics of deformable bodies because it really requires our basic knowledge on statics of rigid bodies. So if you have no clarifications or questions, no, or further queries, then thank you for your participation today and good afternoon, class dismissed.
Bye, sir. Thank you, sir.
Bye, sir. Thank
Sir,
you.
thank you, sir.
Bye, sir.
Bye,
Bye,
sir.
sir.
Thank you, sir.
Sir,
Thank you, sir.
ay sir, pwede ko mangayo sa, ay pwede pa accept ko sir